Hello everyone, my name is Dishant Sethi and I'm currently working as a software engineer at Velotio Technologies. My expertise is in Python and AWS and currently I'm learning Golang as well. And today in this video, I'll be talking about gRPC and Protobuf in Python. Now, since we're talking about gRPC and Protobuf, we'll also compare Protobuf with Json. And at the end of the video, I'll also show you a quick demo how a gRPC server responds when we hit hundreds and thousands of API calls to the server and how fast a gRPC server can respond. Right. So let's start with JSON. So JSON is a simple data object which is used to transfer the data over the wire to other services. It is very easy to implement, very easy to understand. It is human readable. But does that mean JSON is the only solution we have for each and every problem statement we have? So the answer is no. Consider a type of architecture, a microservice architecture, where dozens of services will have to interact with each other. Hmm. So in this case, performance matters the most, and all the services has to handle hundreds and thousands of requests concurrently. So JSON is not the best solution in this case, though we can use the JSON in this type of architecture as well, but it is not the best solution we have. So as an alternative to JSON, we have Protobuf. So the idea behind Protobuf is we take the data object and convert it into a binary string, which is comparatively very smaller in size, and we transfer that binary string over the wire to other services. The other services will use that binary string to deserialize it and get the actual data object and use it in any way the service would want it to use. Right. So as the definition goes, protobufs are basically language neutral mechanism for serializing structured data. Many people might confuse between protobuf and protocol buffer files. In the demo, I'll also explain it. Few of the advantages of protobuf is it's very smaller in size as compared to JSON, since we convert it into a binary string. It prevents schema violation. It guarantees type safety, and since it's very fast, it guarantees fast serialization and deserialization as well. So few of the prerequisites are you have to install protobuf library, Google library, and a proto-C compiler. We'll use this proto-C compiler to generate the gRPC code, the server implementation and the client implementation of gRPC code. This command will take our protocol buffer file as an input and generate the client and server representation of the messages and the services we define in our protocol buffer file. Right. In the demo time, I'll show you how a protocol buffer file looks like. What are messages, what are services, how we can define them, and how we can use this command to generate the server and client representation code. Right. So what is gRPC? So as the name suggests, remote procedural call, it's a modern open source high performance RPC framework that can run in any environment. It can efficiently connect services and across data centers with a pluggable support for inbuilt support for load balancing, tracing, health checking, and authentication. So Google so Google's RPC is defined to facilitate smooth and effective communication between the services, and it can be used in different ways, such as we can use gRPC servers to implement our microservice architecture style, to connect mobile devices, browser clients to backend services, and generating efficient client libraries. Right. Few of the advantages of gRPC is it uses HTTP2 protocol under the hood, which makes it fast and more secure. We have a pluggable support of authentication, tracing, load balancing, and health checking. It is language independent. We uses protocol buffers at the time of implementation of gRPC server. Now, since it is HTTP2 based and protocol buffers, it increases the performance. It supports streaming as well, and since HTTP2 is used, it gives us more security. And now since we use Proto-C compiler, it gives us the auto-generated code of client and server, right? So now there are multiple types of gRPC implementation. First is unary RPC. This is a simple gRPC which works like a normal function call. It sends a request declared in our proto file to the server and gets back a simple single response from the server. Right. The next is server streaming RPC. In this, the client sends a message declare in our .proto file to the server and gets back a streaming message sequence to read. Right, the client reads from that stream of messages until there is no message. Exactly opposite to that is client streaming. In this, the client waits for the server to read all the messages and return a response. Right, and bidirectional streaming is server and client streaming at the same time. Right. Now let's get to the demo. Right. So this is the protocol buffer file which I have written. This is how you write a service, and this is the format in which you define the messages. So right now we have a data object of phone number, a message of person, and details. And this is a service, right? When we pass this service, when we pass this dot proto file to the command which I showed you in prerequisites, it generates these two files, which is nothing but a Python representation of the messages we wrote in the dot proto file and the uh, client and server representation of the service we wrote in the dot proto file, right? So yeah, if we check in this is file, this is the representation of the messages, which is phone number, person, and detail. And this in this we check, this is the class representation of the client and the server, right? Uh, we will inherit this and extend this in our server and the client to write the actual logic which we have to write in our services, right? And I've already defined a gRPC server. I've inherited this from the file generated by the Proto-C compiler. Mm, I This is how you create an object using the person message which we wrote in proto file. It's just that it's the Python representation, which is also auto-generated by the Proto-C compiler. And here in this, I'm returning simply returning the person object which I've created. Now the catch is if when we try to transfer this person object from server to client, it will be converted into a binary string, and that binary string will be transferred to the client. And in this client, I've used uh, that binary string to deserialize it, and after deserializing it, I'll get the actual data, the actual person object, right? So I'll quickly show you how fast it can be. First, I'll run the gRPC server. Now the server is running and listening on 8000 port. And here I've written a code where we'll hit 10,000 API calls to the server and record the time, right? This while loop will run until we reach the 10,000 API calls and exit after that, right? So you can see how fast is this. The gRPC server took 2.3 seconds to complete 10,000 API calls, And what you can do is you can compare it with any Flask server. You can write a very small Flask server and try to hit 10,000 API calls. You will see how drastically time will vary. The normal Flask server in which JSON is passed will probably take 10 to 15 seconds or even more than that. But a gRPC server took very, very less time.